Good morning to all. I'm Karthik, Assistant Professor, Mechanical Engineering Department, SNS College of Technology. Here I'm to give a small lecture on or a small brief note on failure mechanism. We all know any material which is used in any type of applications will be getting failed at some part of time. So in other ways, you can say in most of the time you can say the material has its own lifetime. After that, it gets failure. Or other ways, if a metal is getting failed due to some failure or it is due to some fractures, we should know why it is failed before the end of its lifetime. So that type of searching the reasons behind those failures is nothing but known as failure mechanism. Right. So the next in this we can say there are four types of before that I'll have a small give a brief thing on failure. The failure is nothing but there's a separation of a body into two or more pieces in response to the applied stress that is static and at a temperature that are low relative to the melting point temperature of a material. So in short, we can say fracture is nothing but the material is broken into two or more pieces when the stress is applied at a static or at the moving time or due to some temperature which is relatively lower than their melting point. Here the melting point comes into the picture because at melting point any material is going to convert it from liquid state to solid state to liquid state. But before that time, due to the temperature also, most of the material getting failure. The best part is that due to pre-failure. Before that I will say you can see some rocket engines, rocket casings, boiler casings getting failed because of their exposed to high temperature at a longer time. So this is so not only due to stress, not only due to the mechanical stress, due to the thermal stress also failure do happens. So here there are two types of failures which we are going to see in this video. First is ductile failure. The ductile failure which is accompanied by a plastic deformation. So this ductile failure is comparatively it's a very good type of failure, which because before the material going to get failed, you can have or you can see some changes in the material behavior like necking formation or elongation. Due to that we can easily identify the material is going to have a fracture, so that the replacing of a particular material or particular device or a thing can be done. But the second type of failure is a brittle failure. Here it's a non-plastic failure or there is no indication of plasticity. Means that there won't be any elongation, there won't be any necking formation. Suddenly it gets failed and it have a catastrophic damage. So an application of deploying any material to the application, the material should be tested so that even after application ductile failure may occur, but brittle failure should not occur, which because they won't give any idea when they are going to fail. But if they fail at a sudden rate, so then the catastrophic damage will be more catastrophic, right? Here it's a simple basic thing behind the failure mechanism is only three things. One is imposed stress. So the type of stress what we are imposed on a particular material or metal or device or anything, the imposed stress is the major part. Second one is that due to that imposed stress on the particular material, there may be the formation of crack. So that is a crack formation. When we go on giving a particular stress or a particular or if we go on imprinting the stress on the material, you can see the crack growths or crack propagates. So imposed stress, crack formation, the crack propagation, these are the major three things which is mainly seen in the fracture mechanism. So the first one is ductile failure. Here which is already seen that there will be an extensive plastic deformation before cracking. So and that too this process relatively slow and stable. So the crack can be resisted at the time when the crack starts, so that the stress can, so that the applied stress can be reduced and the fracture can be prevented. But in the brittle fracture, we can't have any significance of the failure going to happen. There can be very little there won't be any little deformation, there won't be any plasticity happens. So the crack which forms in the brittle materials will be, growth is very rapid, the growth propagations are also very fast, and without applying and without increasing the applied stress, you can easily get failure at a fraction of seconds. Okay, so that's all for today. Thank you.